this video, I'm introducing geometrical optics. First, the concepts. So concepts, reflection is light bouncing off of a surface. And this is something, if you've ever looked in a mirror, then you understand what reflection means. It's the light that comes in, bounces back off. Refraction, that was actually what was shown in the previous slide. I'm going to go back for a second. So refraction is light bending when it goes into a material. So there's this interesting pattern back here on the wall behind the glass. The glass is full of water. The area that's all water, the light goes in and is bent so much by the glass and by the water inside the glass, it actually reverses the directions of the stripes. So refraction is describing how that light bends as it passes through a surface. So from the air into the glass, glass into the water, then the water back into glass, and then glass back into air again. So it's a complicated thing passing through that glass. We'll only look at single and double transitions. Converging lens. So a converging lens looks like this. So when light comes into a converging lens, it gets focused down to a point. So these are thick in the middle, thin on the edges, and they focus the light in. A diverging or concave lens, curved on the front, curved on the back, is normally what a concave lens looks like. And this one focuses light in. This one actually spreads light out when it goes through it. Then there's a focal length. If light comes in parallel, then the distance it gets focused to, that's the focal length. Images. So images, if light actually does pass through an area where there's an image formed, then it forms a real image. A camera has a lens on it, and it focuses images onto the detector. Your eyeball has a lens in the front of it. Mine has two. Okay, there we go. Now mine has one in front of it, so that simplifies it a little. So the light comes in, and then my lens in my eye focuses it onto the retina. So those are real images formed on the retina by the light that passes through. Magnification. This projector is creating a pattern inside that little device, and that pattern is only maybe this big. And then there's a lens and a light that projects it up here, makes a huge image of that little thing inside the projector. So that's an example of magnification. So lenses and mirrors, if a mirror is not flat, if it's curved, then it can magnify. So magnification can be positive, which means making it bigger like this, or it can actually reduce an image as well.